Statistical test. In the previous video, we talked about the statistical inferences, and we said that if we want to arrive at a conclusion about our data set, then we need to perform some statistical tests so that we can either be able to accept or reject our null hypothesis. So mainly in statistics, there are two main statistical test categories. We have the parametric test, statistical test, and then the non-parametric statistical test. Now these are the differences. In parametric, it assumes specific distributional assumption about the data, but in non-parametric, it does not assume specific distributional assumptions about the data. So in parametric, there is an assumption. For example, for example, it's expected that the distribution is normal distribution. So that's the assumption made. But in non-parametric, they do not make an assumption. In parametric, it also requires estimation of population parameters. Okay, estimation. So yeah, because you need to be having full data set and all that for you to be able to have a normal distribution. But in non-parametric, it doesn't require any estimation. Deal with the what's available at hand. Also, now in parametric, it makes assumptions about underlying population. There are so many assumptions, we have already talked about it. But in non-parametric, we have talked about it, doesn't make some of those assumptions there. Now, in case the distributions are made, that is normal distribution, then parametric would become much more powerful. But either way, all this depends on, first of all, what is the type of the data set you're having, what is its distribution in terms of a normal distribution, okay. And then from that you can begin figuring out which kind of test are you going to use depending on which method or what objectives you are trying to answer. Now we are going to dive deep into the different examples of the statistical tools, statistical methods under each of these tests. Now, if you want to compare mean between two independent groups, for example, if your research question is, do managers who are men have a higher average salaries than managers that are female? Those are independent groups. If the data set is parametric, let's say a normally distributed, filled up, like all those assumptions are made, parametric test, then you would do a two-sample t-test. A two-sample t-test. If those data set collected did not meet the assumption for a for a parametric test, then you'd do a non-parametric test for two samples, mean, that would be Wilcoxon rank sum test. Now, next scenario, when you want to compare two quantitative measurements taken from the same individual, same person. For example, you want to examine students' diagnostic test results before and after a study. If the data set is parametric, normal distributions, all those other assumptions we talked about have been made, then you would do a pair t-test. But if some of those assumptions for parametrics have not been made, then you are going to do a Wilcoxon signed rank test. Next scenario, if you want to compare the means between three or more independent groups, for example, is there a difference in the crop yield if a farmer uses fertilizer A, B, and C? If the dataset collected is parametric, then you are going to have analysis of variance, or what you call the ANOVA test. But if the dataset collected is non-parametric, then you are going to use Kruskal-Wallis test. Next, estimate the degree of association between two variables. If you want to estimate the degree of association between two variables, for example, does the number of hours a person spends on social media affect the number of hours they sleep at night? Okay. Association between number of hours spent on social media versus the number of hours which are spent sleeping at night. If the dataset collected is parametric, assumes the normal distribution, like all those other factors have been, conditions have been met, then you would do a Pearson coefficient of correlation test. But if those assumptions are not met, then you are going to do a Spearman's rank correlation test. So this is how important it is. This is sometimes referred to as a decision tree in statistics. If you have your data set, how do you arrive at the decision on which statistical method to use? Or if you're designing a research paper, how do you then decide on which statistical method you later use to analyze your data set? This is very important for you to know. Now, we are going to dive into some of these methods, some of them that we can dive into. We shall dive into some of them, like the correlation, regression, some of them that are very, very common. We shall dive into them and we try to talk about them. In case you're interested in knowing more about some of these statistical methods, then make sure you click on this next video so that you explore more about correlation and regression. See you next time. Make sure you subscribe, share this with your classmates, your friends and everybody so that they can also learn the same information. See you next time.